It's to determine the eccentricity of the space station's orbit and the uniformity of the Earth's magnetic field. Just programmed a small computer. I send the program off to AstroPi, who work with the European Space Agency, and then they uplink it to the space station sometime mid-April and then run the experiment for 3 hours, which is equivalent to 2 orbits. My mum showed me a post on Facebook that the Ogden Trust had shared of the Raspberry Pi Foundation that run the AstroPi Challenge. And that Ogden Trust is basically like a science outreach community, and I was a member of that alumni association from winning an award for School's Physicist of the Year last year. Initially, I wanted to experiment with electromagnetic induction, turning a magnet in a coil of wire to induce a current, but the astronauts don't have enough time to sort of mess around with it, so you just have to use the sensors on the actual Pi, and it's got a bit of hardware on top that's got the magnetometer, accelerometer, compass and a gyroscope on, so you've just got to do what you can with them. You have to go through a few stages, so I think they eliminate quite a lot of people as you obviously go through the stages. So there's your initial idea. I just said I was going to record accelerations and determine how it wobbles around in space. From that I realised I could calculate g-force and then work out the eccentricity. Computer science teacher Rob, he's helped me verify the code, make sure it all works, but David's made sure they're all feasible, my ideas, really. I feel like obviously it's a massive opportunity and it's come at the right time for EPQ as well, because that's what I've used it for, and it's quite good to improve your experimental practice, which you get tested on in chemistry and physics, like your practical endorsement. So it definitely helps at the minute. I'll use the research by putting all the data into Excel. I'll get back the X, Y and Z vector components of g-force, and then I'll put all that on a graph which will give me the g-force. And then when I find the maximum and minimum point, I can put that into Newton's law of gravity to determine the apogee and perigee, and then just put that into another equation to determine the eccentricity vector. Hopefully to go to uni and study physics. I think it'll help more in the future when I'm doing stuff like this in a physics degree. There's obviously whole areas of physics that we don't cover in college, like relativity and stuff like that, so I could find some of it that I really like and end up going on to follow that. Before summer it was a toss-up between physics and engineering. My dad's an engineer, so it's sort of in my background, but it's a very different type. It just came out of interest of how things work. Well, when I applied, I knew it'd be an option for it to be sent up, so it's always felt obtainable to me, but to other people it might seem a bit more abstract. I was sending an experiment to space, it's a bit out of reach for them. But yeah, they, everyone else has sort of made it into a bigger deal than I thought it was. It's rare for me. If I hadn't have done it, it'd probably something I would have wanted to do, but yeah, it feels like quite a rare thing, the deal people make of it.